So I want to draw a Bayes rule. Graphically, we have a situation where we have an internal variable A, like whether or not we have cancer, but we can't sense A. Instead, we have a second variable called B, which is our test, and B is observable, but A isn't. This is a classical example of a Bayes network. The Bayes network is composed of two variables, A and B. We know the prior probability for A, and we know the conditional. A causes B, whether or not we have cancer causes the test result to be positive or not, although with some randomness involved. So we know about the probability of B given the different values for A. And what we care about in this specific instance is called diagnostic reasoning, which is the inverse of the causal reasoning. Probability of A given B, or similarly, probability of A given not B. This is our very first Bayes network, and the graphical representation of drawing two variables, A and B, connected with an arc that goes from A to B is the graphical representation of a distribution of two variables that are specified in the structure over here, which has a prior probability and has a conditional probability as shown over here. Now I do have a quick quiz for you. How many parameters does it take to specify the entire joint probability between A and B, or differently, the entire Bayes network? I'm not looking for structural parameters that relate to the graph over here. I'm just looking for the numerical parameters of the underlying probabilities.